Welcome to The Explainer. Today, we're taking on a direct challenge to your imagination. You've probably heard people casually mention the fourth dimension, and maybe you've wondered, what does that actually literally mean? It's one of those concepts that sounds, well, kind of like pure science fiction, right? And because of that, it gets widely misunderstood. But we're going to break the whole thing down. We're going way beyond the familiar world we can see and touch, pushing right past three dimensions to finally wrap our heads around the fourth dimension. So what actually is the fourth dimension? Well, it's a fantastic question to ask. And today, I promise we're going to totally demystify this abstract idea for you. We're going to use a really structured, logical approach to build up your understanding step by step. By the end of this explainer, you're going to have a crystal clear picture of a concept that usually leaves most folks just scratching their heads. Okay, let's dive into this. Part 1. The foundation. Dimensions 1 through 3. Now, to truly understand the fourth dimension, we obviously can't just skip ahead to the complex stuff. We've got to build our foundational scaffolding first, starting with the spatial basics that you and I interact with every single day. And to do that, we need a super simple definition. A dimension is, quite simply, a direction in which you can move. That's it. It doesn't need to be any more complicated than that. Just keep that core concept in mind, a direction of movement, because it is absolutely crucial for unlocking the whole shebang today. All right, let's work our way up. The first dimension, or 1D, is just a simple line drawn right in front of you. There is only one direction of movement here, forward and backward along that specific line. Now, if we add another direction, boom, we get the second dimension, 2D. Now we can move left and right as well as forward and backward. Just think of a flat sheet of paper. And finally, that brings us to 3D. This is our world. By adding a third direction, we can now move left and right, forward and backward, and up and down. Just like that, we successfully built the world exactly as we experience it. Part 2, the biological limit. Imagining the fourth dimension. So the crucial point is that we are biologically limited. Our human brains actually evolved to understand and seamlessly navigate only 3 spatial dimensions. Because we're hardwired for a 3D existence, it creates this massive mental roadblock for us when we try to conceptualize anything beyond it. But what happens if we add yet another direction? What if we push past those biological limits? If we just keep following that mathematical pattern we literally just established, from 1D to 2D to 3D, well, that leads us directly to a theoretical fourth spatial dimension. Even though we can't directly see it, and yeah, we can't effortlessly picture it in our minds, logic dictates that it's the natural next step in the sequence. To really grasp this limitation, I want you to imagine a tiny creature living entirely on a flat, 2D sheet of paper. It has absolutely no concept of height. None. So if we take a 3D object, like a solid cube, and pass it straight down through that paper, the poor little guy wouldn't see a cube. No way. It would only see a changing two-dimensional shape appearing and kind of morphing across its flat world. It would never fully comprehend the true 3D cube. Now, shift your thinking to our 3D world. That's us. If a truly 4-dimensional object passed through our 3-dimensional space, we wouldn't see the whole thing either. We would only see a 3-dimensional cross-section of it changing right before our eyes. We are exactly like that 2D paper creature, completely limited by our own dimensional perspective. Mind-blowing, right? And this brilliantly illustrates what happens when we use theoretical math to push those very boundaries. We get objects like the Tesseract. A tesseract is essentially the 4-dimensional equivalent of a cube. Think about that progression again. Just as a flat 2D square can be mathematically extended into a 3D cube, a 3D cube can, theoretically, be extended into a tesseract simply by adding another spatial direction. It's a total mind-bending 4D shape that our math proves can exist, even if our biological eyes just cannot behold it in its true form. Part 3. Grounding in reality. The role of time. Let's move to and see how this builds into something far less theoretical. We're executing a big turn right now, shifting our explainer from abstract geometry over to modern real-world physics. Because here is the incredible truth. In modern physics, the fourth dimension isn't just some mathematical curiosity scribbled on a chalkboard. It actually refers directly to time, which means you and I are actively navigating the fourth dimension right now. According to the theory of relativity, developed by Albert Einstein, space and time are not separate entities. Not at all. They're actually deeply connected into a single unified structure called spacetime. Because of this beautifully unified structure of the universe, to describe any event completely, scientists need exactly 4 coordinates. You need your x-coordinate for left and right, your y-coordinate for up and down, your z-coordinate for forward and backward, and, crucially, your t-coordinate for time. Time is simply an essential additional data point required to pinpoint reality. Think about it like this. Knowing where you are is not enough. We also need to know when you are there. Like, if I tell you to meet me at a very specific latitude, longitude, and elevation, perfect 3D spatial coordinates, but I completely forget to tell you the time of day or the year, well, we're literally never going to meet. Your spatial location in the universe is fundamentally incomplete without your temporal location, and that is precisely why modern physics treats time as the literal fourth dimension.
Now, what's really interesting about this lie is realizing the immense power of the human mind. The fourth dimension remains the unseen dimension. It's one of the most fascinating concepts in both math and physics, precisely because we physically cannot directly see it with our limited biological eyes. Yet, through our application of logic, through the strict rules of geometry, and through rigorous scientific theories, we can mentally visualize and deeply understand the very fabric of the universe that remains totally hidden from our physical sight.
Which brings us to a final provocative thought. If knowing when is truly just as important as knowing where, how does the fourth dimension change your view of reality? The next time you walk down the street or arrange to meet a friend, just remember, you aren't merely moving through three-dimensional space. You are actively traveling through space-time. I really hope this structured journey has completely shifted how you see your place in the universe. Keep expanding your mind, stay curious, and we'll see you in the next explainer.